So, good morning, good day, everyone. We are the Group 3, and we are here to present and discuss the variable load problems, diesel power plant, gas turbine power plant, tidal and biomass, and the power plant economics. So, for the first topic, variable load. Under this topic is RD, load curves, important terms and factors, units generated per annum, load duration curve, types of loads, and the typical demand and diversity factors. Next slide, please. So for the variable load, it is the variation in load of power stations that need changes from time to time due to uncertain demands of the customers. An electric power station is designed to meet the load requirements of the consumers. From the standpoint of equipment needed and operating routine, an ideal load on power station would be of constant magnitude and steady duration. So, ang variable load natin is since ang variable load natin is changes over time to time, kasi nakabase siya sa demand ng ating consumers. If they want to increase it, decrease it, or still remain dun sa capacity na kaya ng ating power plant station. Next slide, please. So, ano nga bang effects ng variable load sa ating power station? So, ang una dyan is yung need ng ating power station sa additional equipment. So, imagine na lang natin na sa isang steam power station, so ano yung mga variable raw materials ng ating power plant? Ang una dito is the air, the coal, the water. So, in order to produce yung variable power na kailangan ng ating power station, yung supply natin is required to vary correspondingly. Meaning, if the power demand on the plant increases, yung increased flow ng ating raw material must follow. Increased flow ng ating coal, air, and water sa boiler natin in order to meet yung increased na demand ng mga consumers natin. So pangalawa, increase in production. So imagine na lang natin, increase in production cost. So imagine na lang natin na sa isang power plant station, so tumaas yung variable load natin. Iisa lang yung alternator na ginagamit natin doon. So automatically, yung efficiency na bababa. Diba? Kasi ang taas ng demand tumaas yung demand ng ating consumer. So ang solution doon is number of alternator of different capacities should be installed in the power plant station so that yung most of the alternators natin can be operated at nearly full load capacity and will increase its efficiency. So pangalawa is anong effect ng variable load natin sa power plant design? So nilagay ko dito is more steam increasing the turbine speed to its normal value. So since tumaas na yung variable load natin, mare-reduce yung rotational speed ng turbo generator natin. Kasi nandun lang yung normal Nandun lang yung normal. So ang solution dan na gagawin is yung the governor will come into action, then will operate a steam valve and sasabihin na mag-admit ng more steam para ma-increase yung turbine speed natin to increase and produce more electrical energy. So, yung increase ng steam natin will be supplied by the steam generation dahil nga nag-admit ng ating governor na magtaas ng steam. So, pangatlo na effect ng variable load natin is sa power plant operation. So, bakit nga ba nilagay ko dito yung readiness to service? So, even though the availability ng mga service ng ating power plant station, ng ating modern power plant stations is very high, Usually kasi siya more than 95%. Meron pa ring times na there will be a problem, malfunction sa ating mga operator, sa ating mga equipments. That is why yung ating mga power plant station is still remain sa readiness to service basis. Bakit? Kasi in terms of calamities yan, ang mga power plant station natin should be ready to service sa mga gantong unexpected events. So itong capacity na tinatawag dito, capacity called ng pagiging readiness to service is what we call the spinning reserve. So it represents the equipment standby at normal operating conditions of pressure, speed, and variable load demand. Next slide, please. Yan. So for our load curves, the curve showing the variation of load on the power station with respect to time is known as a load curve. So the load on a power station is never constant. It varies from time to time. These load variations during the whole day are recorded half-hourly or hourly and are plotted against time on the graph. The curve thus obtained is known as daily load curve as it shows in the variation of load time during the day. So makikita natin dito sa table, for our y-axis, we can see the variable load in megawatts na napoproduce ng power ng station natin, power plant station. Then in y-axis is yung time. So ano ang mapapansin natin dito sa table na to? Ang ibig sabihin dito na from 6 p.m. mataas yung variable demand ng ating mga consumers. So possible kasi na since ang mga trabaho natin, trabaho ng mga nanonood is commonly pang umaga, then pag uwi nila, yan gagamit nila sila ng kung ano ng electronics. Then effect nun is mataas yung variable load na mapoproduce. Then mapapansin din natin na tuwing 7 a.m. pagkagising and the 1 p.m. after lunch, mataas din yung variable load demand ng ating mga consumers. Next slide, please. Ayan, so important terms and factors. It is the sum of continuous ratings of all the equipments connected to a supply system is what we call the connection load. It is the greatest demand of load on the power station during a given period is what we call the maximum demand. And for demand factor, it is the ratio of maximum demand on the power station to its connected load. So for our formula, unang formula natin for demand factor is demand factor is equals to maximum demand over connected load. So for average load, it is the average load occurring of the power station in a given period, day or month or year, is known as average load or the average demand. So for the formulas, daily average load is equals to number of units in kilowatts generated in a day over 24 hours. So since it is in daily average load, monthly average load is equals to number of units in kilowatts generated in a month. So number of hours naman dito is in month, yung hours in a month. So yearly average period is equals to number of units in kilowatts generated in a year. So year, meron tayong 8,760 hours. So for our load factor, it is the ratio of average load to the maximum demand during a given period is known as load factor. So for the formula, load factor is equals to average load over max demand. So if the plant is in operation for 3 hours, ang load factor natin is equals to average load times T over max demand times T. Also, unit generated in T hours over max demand times T hours. For diversity factor, it is the ratio of the sum of individual maximum demands to the maximum demand on power station is known as diversity factor. So for our formula, for diversity factor is equals to sum of individual max demands over max demand on power station. For plant capacity factor, it is the ratio of actual energy produced to the maximum possible energy that could have been produced during a given period. For plant capacity factor is equals to actual energy produced over max energy that could have been produced. So, paggamit naman natin uli is yung T. Average demand times T is divided to plant capacity times T. Also, average demand over plant capacity. Thus, if considered period is 1 year, ang ating formula is equals to, ang formula for annual plant capacity factor is equals to annual in kilowatts output over plant capacity times 800, 8,000, 8,760 hours. So the plant capacity factor is an indication of the reserve capacity of the plant. A power station is so designed that it has some reserve capacity for meeting the increased load of demand in the future. So sinabi ko nga na hindi dapat ang power plant station natin is in ready to serve basis kasi ang ating variable load depends sa ating mga consumers. Therefore, the installed capacity of the plant is always somewhat greater than the maximum demand on the plant. Meaning, reserve capacity is equals to plant capacity minus yung ating max demand. Next slide, please. So, for our plant use factor, it is the ratio of kilowatts in hour generated to the product of plant capacity and the number of hours for which the plant was in operation. For the formula, plant use factor is equals to station output in kilowatts over plant capacity times hour of use. Next slide. So for units generated per annum, it is often required to find the kilowatts generated per annum from maximum demand and the load factor. The procedure is as follows. So for our load factor, since ang gamit na natin dito is generated per annum, then average load is divided to max demand. So average load natin is equals to max demand times ating load factor. So for our units generated per annum, the formula will be average load in kilowatts times yung hours natin in a year, which is 8,760. And also, units generated per annum is equals to max demand in kilowatts times the load factor times yung hours natin in a year.
Load duration curve. When the load elements of a load duration curve are arranged in the order of the descending magnitudes, the curve thus obtained called load duration curve. And as we can see in the graph presented in the load curves, that um, the load curves present that uh, the load is with respect to the real time a day, which we can see that 8 a.m. to 4 p.m. is the highest load commonly happened a day, since it is a day or time where the sun is up. And for the second one, represent the load with respect to hours duration, shows that the use of highest load in a day was 8 hours. Next. Note that the following points may be noted about the load duration curve. The load duration curve gives the data in a more presentable form. In other words, it is readily shows the number of hours during which the given load is prevailed. The area under the load duration curve is equal to that of the corresponding curve. Obviously, the area under daily load duration curve in kilowatt hour will give the units generated on that day. The duration curve can be extended to include any period of the time by laying out the abscissa from 0 hour to 80760 hours, which is a hour on a year. The variation and distribution of demand for an entire year can be summarized in one curve. The curve thus obtained is called the annual load duration curve. Uh, Types of load. Domestic load. Domestic load consists of lights, fans, refrigerators, heaters, television, small motors for pumping water, etc. Most of the residential load occurs only for some hour during the day. Example given, lighting load occurs during the night and domestic appliance load occurs for only few hours. For this reason, the load factor is low, 10% to 12%. Commercial load. Commercial load consists of lighting for shop, fans, and electrical appliances used in a restaurant, etc. This class of load occurs from for more hours during the day as compared to the domestic load. The commercial load has a seasonal variation due to extensive use of air conditioner and space heaters. Industrial load. Industrial load consists of load demand by industries. The magnitude of industrial load depends upon the type of industry. Thus, small-scale industry requires a load up to 25 kilowatt, medium-scale industry between 25 kilowatt and 100 kilowatt, and the large-scale industry requires load above 500 kilowatt. Industrial loads are generally not weather dependent. Municipal load. Municipal load consists of street lighting, power required for water supply and drainage purposes. Street lighting load is practically constant throughout the hours of the night. For water supply, water is pumped to overhead tanks by pumps driven by electric motors. Pumping is carried out during the off-peak period, using occurs during the night. This helps improve the load factor of the power system. Irrigation load. This type of load is the electric power needed for pumps driven by motors to supply water to fields. Generally, this type of load is supplied for 12 hours during the night. Traction load. This type of load includes the tramcars, trolleys, buses, railways, etc. This class of load has wide variation. During the morning hour, it reach peak value because people have to go to their workplace. After morning hours, the load start decreasing and again rise during the evening since the people start coming to their homes. Typical demand and diversity factor. The demand factor and the diversity factor depend the type of the load and its magnitude. So as you can see, we have a different type of electricity consumer that has a different requirements of supply load. That we have the residence lighting, commercial lighting, general power service, and in it includes the different requirements, demand factors, and etc. Note that the load and demand factor are always less than 1, while diversity factor are more than unity. High load and diversity factor are the desired qualities of the power system. Indeed, these factors are used to predict the load. Problem solving.
Okay, so for our problem solving number 1, a generating station has a connected load of 43 megawatts and a maximum demand of 20 megawatts. The units generated being is 61.5, times 10 raised to 6 per annum. Calculate the demand factor and the load factor. So, as I discussed earlier, demand factor is equals to maximum demand over connected load. So, substituting the given 20 megawatts over 43 megawatts is equals to 0.465. So for our load factor, since it is equals to average demand over max demand, so first we need to calculate the average demand. So originally, no equation natin is units generated per annum is equals to average demand uh, times hours in a year. So for average demand natin is equals to units generated per annum over hours in a year. So as given, yung units generated natin per annum is 61.5 times 10 raised to 6 over yung hours natin in a year is 8,760. So dividing, ang sagot natin is 7,020 and ang ating unit for average demand is in kilowatts. So therefore, yung load factor natin is equals to average demand times over max demand is equals to yung 7,020 kilowatts natin over. So since yung ating 20 is in megawatts, times natin times 10 raised to 3, then 7,020 over 20 times 10 raised to 3 is equals to 0.351 times 100 natin kasi load factor ang hinahanap natin dito. And it is equals to 35.1%. So, ang ating demand factor is 0.465 and for our load factor is equals to 35.1%.
Okay. Example number 2. A 100 megawatt power station delivers 100 megawatt for 2 hours, 50 megawatt for 6 hours, and is shut down for the rest of each day. It is also shut down for maintenance for 45 days each year. Calculate its annual load factor. So, um, calculate natin yung load a day since nagwo-work yung power station natin with a 100 megawatt for 2 hours and 50 megawatt for 6 hours. Then energy supplied for each working day is the 100 times 2 plus a 50 times 6 equals to an overall working of the power station a day is a 50 megawatt per hour. And for the days operation, which is we have a one year 1 year equals to 365 days. Station times the station operates a day per day a year. 500 times 320 equals the 160,000 megawatt per hour. And to calculate the annual load factor equals to megawatt hour supplied per annum over maximum demand in megawatt times working hours times 100 since annual load factor yung hinahanap natin. Substituting the value 160,000 over 100 times 320 times 24 times 100 equals to 20.8%.